binomial theorem for any positive integer n. For this, first we write binomial expression a plus b having index n. We will expand it just like we did in earlier examples. That is a index n, no b at all here with a at first. Then the power of a decreases as goes on, n minus 1 n, and b starts to appear, and the power of b increases as goes on. Again a n minus 2 b square. This will go on up to last term, which is a 0, that means not at all. The last term is b index n, and the previous term from the bn is, it will be b n minus 1 and a, because from here a will start increasing and no a here at this point. Let's write the coefficients for this expansion. So the index is n, we will write n c 0, n c 1, n c 2, and the last one is n c n, and the previous from this one will be n c n minus 1. Okay, that's how we will write the coefficients. Now we are going to prove this theorem with the help of principle of mathematical induction. To prove binomial theorem, we use the notation Pn to denote the mathematical statement. That is, Pn is such that a plus b index n, and we know what is the expansion of a plus bn is, and this is this. This is the expansion of a plus bn, just like here. In this equation, when n is equal to 1, then as I have put the value of n here, so I will write 1 instead of n. P1 is such that now I'm going to write this a plus b binomial expression, a plus b, and in place of index n, I am writing 1. That is equal to, so 1c0, that's the beginning, that's the last term, which I already told that beginning and the last term is equal to 1. Then simply this will be a1 plus b1, which is a plus b. Thus the p1 term is true. That's what it is saying, that it's equal to a plus b, and it is true. By the principle of mathematical induction, in this, if p1 is true, as we did earlier, and for what? That is for Pn is true for n is equal to 1. This notation in binomial theorem. This is first part. Second, Pm plus 1 is true when Pm is true. That is, it says if Pm is true, which implies Pm plus 1 is also true. How? Let's see in the binomial theorem. We have cleared this stage. Now the turn of this second one. So for this we will take Pm, because if Pm is true, then Pm plus 1 is also true. If all these proven in the binomial theorem, then Pn is true for all natural numbers. So previously it is proven that P1 is true. Now we are going to prove Pm, but here I am going to take it as PQ, or you can take any alphabet, PC, PD, whatever you like. I am taking PQ. Suppose PQ is true for some positive integer q, that is, now again the same binomial expression but with the different index notation. A plus B, index is q, just expand it just like before, and we got QC0 AQ plus QC1, as the index goes on decreasing for the A, I will write Q minus 1 B. See, B appears as it starts increasing from this point. QC2 AQ minus 2 B square plus, and this way it will go on till the last term, and the last term was QCQ and BQ. This is our first statement. By the principle of mathematical induction, we have written for Pm here. Now it's time for the Pm plus 1. Proving PQ plus 1 is also true. Same, you have to write the index Q plus 1 instead of Q, and you have to expand this binomial expression just like before. Only the index will change. So here we go. A plus B. Now I'm going to write Q plus 1 for the index. Then Q plus 1 for coefficient, C 0, and what will come here for the index of A? Simple A Q plus 1. Q plus 1 C1 A. What will come here in the place of Q minus 1? Because we already have here Q minus 1 and we have to write Q plus 1. As we know, A decreases by 1 at each term. So simply what we will do, Q plus 1 minus 1. So what will be left behind? You will simply cut. What will be left behind? This Q. So write it clearly. We got Q. AQ. Now the B starts from here. So I will write B. with no index plus q plus 1 c2, then a q plus 1, but this time it's minus 2. So what we have here, I think minus 1. And b's power goes on increasing. So I will write b square plus, it will go on like this, and I will pick the last term. And our last term is q plus 1 c q plus 1, and b's index is q plus 1. Now we know that a plus b index q plus 1. How we will write this? A plus b, simple, as we have 1, then another is a plus b power q. We will put the value of this first expansion into this equation, and we get a plus b in the first expansion.